the YouTube lands, and I'm going to share the event out one more time.
On the YouTubes.
Yep. So we're going out live on Google+, on YouTube, and yeah, that's it, but that's enough. And this Hangout will be watched by both, well, it'll be consumed, I guess is the correct word, both by people watching it live and on YouTube in the archive. But then we also strip out the audio and put that out as part of the 365 Days of Astronomy podcast.
Okay.
So all in all, we get a pretty good audience. There's usually 5,000 to 6,000.
Wow, that's great.
And yeah, so and someone just posted the strangest picture. Oh, I understand. I have Twitter open looking for questions, and someone found a kitten that looks kind of like Michi Yukaku with its paws up, and then they labeled it aliens. So, yes. The random things that come up in the corner of your eye when you are following Twitter to see what happens.
Not as good as the cat that looks like Kylo Ren. Have you seen that?
No, I haven't seen that yet. I'm gonna have to find that. Have you? Are you on social media very much?
I have a Twitter account and I do a little bit on that, not too much. RIS has a Twitter account that that I do stuff on, our education public outreach lead. She posts to that a lot. I'm mostly on Facebook, but even there, I tend to be more of a lurker than a poster.
That's totally fine. There's a new account. It's Bad Father Han Solo or something like that, which is a compliment to the emo Kylo Ren Twitter account, and they'll actually go at it periodically. Go ahead.
And there's like a lonely Luke Skywalker too, right?
Yes, yeah, I'm following that one as well. I love these parody accounts.
Well, the original is a sad Darth Vader.
Yes, but that one hasn't been active very much.
Right?
Yeah, it's depressed Darth Vader.
Sarah Noble turned me on to that one. If you know.
Of course she did. Oh, you don't know Sarah?
Oh, Sarah Noble. I heard Barry Noble, and like Barry Noble isn't the person I know. And then I realized, no, I just can't hear.
I don't know if she still tweets, but there was a person that tweeted with the handle Hot Amish Chick.
I haven't seen that one.
It's been, I don't know, probably 4 years since I've seen anything, but it was really funny.
One of the ones that I've been enjoying lately is Man Who Has It All, and he's tweeting as though men had to deal with all of the random biases faced by women, and so it's just seeing everything brought to light that you don't realize until you gender reverse sentences. It ends up being absolutely hilarious while making you want to drink heavily.
What's that one called again?
I think it's Man Who Has Everything.
Okay.
I posted it up in the Equality and Diversity Facebook group a couple days ago. Okay, so I should probably get this thing going. We still don't have a live audience. That sometimes happens. They will either join in progress or, hey, we'll just have viewers on the archive, and that's completely fine. So everyone ready for the official beginning of the show?
Beam face on. There you go.
Okay, Andy, sit up or move your camera. Okay. Okay, and hair back, I've been told. Sorry, Andy. Hello and welcome everyone to the Center for Lunar Science and Exploration Team Hangout. Once a month on the first Tuesday of the month, we bring in a different part of the survey teams that are out there trying to help us figure out how to explore the moon, other small bodies in our solar system, and the moons of Mars. Please follow us on YouTube. catch all of the different teams that we've already seen and subscribe so that you can catch all of our upcoming episodes. This week, we have Tim Glotch, who's with us from Stonybrook University, and he is in charge of the RIS team, which you may have heard pronounced as the RIS4E team, but the 4 is actually silent. So there's a bit of confusion on that, but we're here to clarify. It's the RIS team. Can you tell us a little bit about the team you've put together and what all you're doing, Tim?
Sure thing. Our team is based around kind of 4 key science and exploration themes. The first we call preparation for exploration, where we're essentially doing laboratory spectroscopy. So looking at minerals and meteorites and lunar samples in the infrared light in the lab that helps us interpret the data that spacecraft are returning. Right. So we have an armada of spacecraft throughout the solar system, looking at the moon, Mars, asteroids, and those data can be somewhat difficult to interpret depending on what the conditions that they're acquired in, the temperatures, the angles between the hey, thank you, awesome. Angles between the sun and the surface. So this lets us better quantitatively interpret those data, which is a main goal of ours. And this is kind of really my research bread and butter. Our second theme is basically focused on field work, and we call this maximizing exploration opportunities. And our goal, we have a few goals here. One is to help us understand once we send human explorers back out into the solar system, how can we give them the tools that they need to figure out what samples to bring back and how to explore most effectively. So we conduct field work with a relatively large team. The last 2 years have been in Hawaii and Kilauea, which is a great lunar and Mars analog. The next 3 years we're going to be in the Potrillo volcanic field in New Mexico, looking at rocks there. But we want to understand, what types of handheld scientific instruments are useful and which are kind of they're neat toys, but they're not quite useful in the field right then in the moment. Then the other thing we try to do is work with astronauts and other scientists who are involved, and other scientists and individuals who are involved in exploration to figure out the ways to kind of maximize the time spent in EVA's extravehicular activities. So that's what that theme is all about. The types of tools we're using there include X-ray diffraction instruments, infrared cameras, X-ray fluorescence instruments, LiDAR, which is basically laser shooting at a surface to help us figure out the topography and the distances to things. All of these things could either be useful with an astronaut holding them in their hand, or maybe if an astronaut has a rover robot buddy, you might mount cameras or LiDAR on a robot assistant.
I'm a fan of the robot buddy, and the type of work that you're doing. Well, your hope is to eventually have the human beings out there. You can still mount up a robot with all of these instruments and check things out first, and so this is broader impacts.
Sure thing. I think our team is kind of evenly divided between folks who concentrate a lot on robotic exploration of the solar system. That's a little bit faster, cheaper, certainly safer in terms of human capital. But I think we all recognize to eventually explore the solar system in a way and learn as much as we can about it. We require humans who can be there on the ground and think and make decisions in real time. So we're trying to attack things from both sides, right?
And that bridges nicely into your third theme of protecting our astronauts, our explorers.
Right. So we recognize that our space is dangerous, and there are hazards that our astronauts will be exposed to. And so one of those main hazards is dust. The surfaces of the moon, other airless bodies like asteroids, Phobos and Deimos, the moons of Mars, they're covered by a very fine dust regolith. Of course, astronauts, when they're out there on the surfaces, they will be in suits and helmets. They won't be breathing that dust in, but once they go back into their spacecraft, they'll be exposed to that. And so we want to understand what the effect of that dust is on primarily respiratory health, but also longer-term health. So the Stonybrook Geology Department is teaming with actually our pharmacology department, our medical school, to test right now lunar dust simulants. We're using mouse lung and brain cell cultures. We're not using live animals, but brain and cell cultures to understand how dust affects both cell inflammation, maybe which can later on lead to fibrosis and cancer, but also DNA damage, and so kind of longer term, more chronic things. Eventually, we're going to work our way up to looking at real lunar and asteroid materials in the form of meteorites. But right now, the first couple of years, we're trying to make sure we have all our protocols down, and we want to make sure we know exactly what we're doing before we start using some of that really precious extraterrestrial material. But the whole goal is to make sure that when we send astronauts to these bodies, that we are protecting them to the maximum extent possible.
And it's really kind of amazing how brutal this space dust is, because it is in large part silica, which is like the stuff that goes into glass.
Sure, and there's heavy metals in them too. There's iron. The surfaces of airless bodies have a thin patina of an amorphous glassy material with nanophase metallic iron and other iron-rich materials in them. Those are highly reactive. When those react in lung fluid in your lungs, they generate things we call HROS, which is highly reactive oxygen species. Those are things that attack cells and can lead to inflammation and other problems. So we want to understand how these highly reactive oxygen species are generated, and what, if anything, can be done to mitigate those effects as well.
Tim, do you know if there was any data from from the Apollo program? Was there any data from the effects of lunar dust on the astronauts' lungs? And if there is, are you using that as are you maybe trying to build off of that data?
So there certainly have been teams at Johnson Space Center and others that have looked at this. A lot of the work that we've seen has been kind of anecdotal reports of what they call astronaut hay fever. So they would breathe things in and they'd sneeze. They reported that and it would go away after a few days, right? So if it's very short duration exposure, then it's probably not an issue. But if we're talking about longer term missions, then it could be an issue. The astronauts reported that the lunar dust smelled kind of like gunpowder, so there's some kind of reaction, going on. But there has been medical research going on in the past, but right now we have the certain types of tools that weren't available in the 60s to look at chemical reactions that occur on the microscale. We can use animal models as well as things like just simulated lung fluid, which is water with some lipids and fatty things in them. I'm not a medical geologist, so I don't really quite get this. Leave that to my more experienced co-investigators. But we can do things in a much more detailed way than have been done in the past. That's a great question.
Yeah, okay, on to happier things. Let's look over at theme 4, which involves less death. Yeah. So theme 4 is maximizing science from returned samples. So there are some really cool sample return missions planned. Which ones are you guys most looking forward to, and what are you trying to do science-wise with these rocks from space?
Sure. So another way that I like to think about this theme is using really big machines to look at really, really small things, right? So right down the road from Stonybrook is Brookhaven National Laboratory, which is actually a Department of Energy facility. But this is a type of facility called a synchrotron facility, where we accelerate particles to kind of 99.999 something % the speed of light, and as those particles are accelerated around this ring, they shoot off high energy X-rays, infrared light, and we can focus those beams, those very high energy and high flux beams, into very tiny spot sizes, and we can do X-ray spectroscopy of samples at the kind of 100 to 50 to 100 nanometer spatial scales, which is great. It lets us look at really small amounts of material and really up close. So some of the things we're really interested in looking at Brookhaven are samples that will be returned by Hayabusa 2, the Japanese mission. Certainly the OSIRIS-REx mission is going to bring back some samples. Right now we are looking at samples that have already been brought back by Stardust and Hayabusa. So we have a lot of work to do with samples that are already in hand, and we have plenty of work to do in the future as those samples return missions. And we think, for something like Mars sample return or something that's a little bit further in the future, we'll actually have X-ray beams that are high flux enough and strong enough that if the tubes are designed right, they're going to be held in this kind of stainless steel aluminum tubes. If those are designed correctly, we might actually be able to penetrate through those with the X-ray beam and analyze the samples in situ, determine the mineralogy and the chemistry without ever actually opening the containers, which
cool.
can expose them to the terrestrial atmosphere and do all kinds of stuff to basically change them before we ever get to look at them. So that's a potentially exciting application. We're kind of looking and doing studies to figure out whether we can do that right now or not.
Now all these things that you're doing, you're spanning robotics, human space flight, exploration, high energy I guess it's high energy geophysics at this point.
Sure.
To do all of this with your team, you have, in addition to you and your deputy director, 24 PIs and co-Is and another 19 collaborators.
Yep.
How did you pull this amazing interdisciplinary team together?
Well, I started by thinking, when I started thinking about writing this proposal, I said, well, who do I like to work with and what do they do? So I pulled together kind of our 4 theme leads. So each of those themes has a lead. I'm the lead for theme 1. Jacob Bleacher at Goddard, who was my graduate school housemate and classmate, he's the lead for theme 2, our field lead. Martin Skonen, who's another professor at Stonybrook and kind of one of the founders of the field of medical geology, he's the lead for theme 3. And Darby Dyer, who's been a collaborator of mine for a long time at Mount Holyoke College, she's the lead for theme 4. So I started by getting those 4 people together, on a telecon. We hashed out some ideas. It was important to us not just to kind of take these 4 separate things and kind of paste them together into a proposal, but really figure out how we could kind of intermingle them and make the sum greater than the whole greater than the sum of the parts, right? So we figured, talking to those 4 people or to those other 3 people, what else do we need? Who has expertise that can bridge gaps between our 4 science themes? We kind of built out the rest of the team that way. And I'll mention, besides the other PIs and co-Is and collaborators that you mentioned, we have a huge, I'll say huge. We have like 10 or 12 graduate students and 5 or 6 postdocs that are doing a lot of science and doing a lot of really good work for us as well. So kind of some of the younger generation folks as well. And one of our big goals of RISE is to help train the next generation of planetary explorers and scientists.
And one of the things that I really appreciate about what you're doing is you aren't just dealing with your standard science students. You're looking to also bring in, journalists and computer scientists, and you're working with the people who have the expertise to help you get your story out so that other people can really understand what you're coming to. And I'm going to pull up the Steps to Space website, and I'd love it if you could tell our audience about your Reporting RISE program that you have.
Sure, that'd be great. Let's see, bring that up. So I'll start off by kind of describing what this is. In 2015, for RISE, we actually created through the Stonybrook University School of Journalism a new science journalism class, and this class had about 8 students in it, 6 undergrads and 2 kind of master's level students. And throughout the course of the semester, they interviewed scientists in RISE. They did lab tours at Stonybrook. They went to Brookhaven National Lab. They went down to Goddard for a day trip. So they learned all about the work that RISE scientists are doing. They developed relationships with the scientists and wrote profiles and stories about them. And then our spring fieldwork last year, they actually we sent 5 students and a TA that were kind of embedded in the field for 10 days with our science team. And so they conducted interviews in the field with the scientists. They followed them around with camera equipment and recorders and notebooks all day. They really kind of proved their field chops. They did a fantastic job. And then their kind of polished product is this reportingrise.com. Where they put together, lots of great video, long format journalism stories, and our goal here was, to really kind of start to, show young people a path towards a science journalism career. one of the other things that we really do quite a bit of in our education and public outreach plan is work with scientists on the other side to teach them how to be better communicators, right? So we have at Stonybrook, we have a great asset, the Alan Alda Center for Communicating Science, and so we work with them to hold workshops to teach scientists how to communicate better to the public, to each other, to stakeholders in public office. But we really want to approach this from both sides. One, scientists teaching them how to communicate better, but also journalists who might not be science majors. None of these journalists were science majors and don't have a lot of experience science beyond high school, but teach them how to talk to scientists and how to get the story of the science out of the scientists. And so those two things together were, I think, very powerful. And we're going to do this this experiment again with the science journalism students in the spring 2017 semester, which we're really excited about as well.
This is a really amazing experience, and I have to admit I'd love to be one of your journalism students out there jumping across the lava rock and exploring the Mars simulated environment. It looks really amazing what you let these students learn and experience firsthand.
Well, I'll say, they really stepped up to the challenge. They did a fantastic job. We're really proud of them.
And so you're working with basically universities and science centers all over the place on this scientific narrative that spans all of exploration and science, which means you're also spanning directorates at NASA, which means your paperwork is significantly more difficult, but Survey is there to help at least.
Sure.
As we look towards the future, what different places are you plugged in to our advancing NASA goals from Orion to OSIRIS-REx?
Yeah, so moving forward, I think Survey has the exact right philosophy, and the kind of the core tenets of Survey is science enables exploration and exploration enables science, right? Whenever you hear kind of a NASA person talking about exploration, they're usually talking about human exploration of the solar system, and sometimes that is that tension with scientists and the goals of scientists, right? Because there's certain pots of money, and some's got to go here, some's got to go here, right? And traditionally, at least for the last, since the end of Apollo, a lot of planetary geology and planetary science and astrophysics has, been done by robots, right? So there is some tension there, but what Survey is really trying to do is ease that tension and actually bring those those two things, science and exploration, into cooperation. And I think Survey is a great example of how you can do that right. And that's what we're trying to do with our team. We've really tried to embrace that philosophy. And we're still learning how to do that. This is a relatively new kind of experiment, between Human Exploration Operations Mission Directorate at NASA and the Science Mission Directorate. But so far, I think it's been incredibly successful. We've been, our team, all of the teams have been scientifically productive. They're paving the way to show how astronauts can operate and future human explorers can operate in space, what technologies are needed to be developed to ensure safe exploration. So whether you're talking about kind of the engineering side with launching of rockets, which we don't have much to do with at all, or the kind of the end goal, which is to learn as much about the solar system as we can, whether we're doing that with robots or humans. I think Survey is playing a crucial role in filling a really important niche in terms of bridging that gap.
Now, as we look to the future, we're finally starting to be at a point where the Google Lunar X Prize teams are hoping to be roving, maybe even by the end of this year. We have Elon Musk's rockets are making ever closer and closer progress to consistently landing on the barge. They just need to remember not to skip leg day anymore. As we look towards the future, what is the thing that has you most excited that we're so close to accomplishing?
Well, I'm really excited by the prospect of sample return, from asteroids, from Mars, getting samples of planetary surfaces with a known geologic context, where we can say it's not just some meteorite that came from somewhere where we can learn a lot about a planetary body that way, but a sample from a known place on a planetary surface where we have kind of global context. that's something that I'm really excited about. But I'm a lab geek, right? So I like, I want to take those samples, bring them to the synchrotron, or bring them in my lab where we can do infrared spectroscopy on those things and learn about these planetary bodies. Looking further out, I think you have to be really excited about the prospect of human exploration and humans, men and women, doing science on these planetary surfaces. And I think that's something that's going to be really exciting for both scientists who are going to get to look at that data, but also for the public who are going to be really invested in that type of exploration, moving beyond kind of low Earth orbit where we've been stuck for however many decades.
Our lifetime.
Yeah, our whole lifetime. And getting out there and really kind of exploring our really just our tiny little corner of the kind of galactic neighborhood, right? We're not talking about going very far out, but even that is a challenge, and rising up to that challenge and getting out there.
Great way to fit in the name of your project.
At this point, it's automatic, right?
So where can people learn more, and how can students apply for next year's Alan Alda program if you're ready to start announcing things like that?
So there's a few things you can do. We're going to be sending out a notice for undergraduate students who are interested in doing research with our team. We hire 6 or 7 student interns to work not just only at Stonybrook, but at institutions all over the country affiliated with RIS. So we send out notices through the Planetary Exploration newsletter. We'll probably go out on the Lunar L listserv. It'll be advertised on social media, Facebook and Twitter as well. So for undergraduate students interested in science, you can do that. The main universities doing RISE Science are Stonybrook, Mount Holyoke College, and University of Chicago. And so those students interested in doing RISE Science might look at the geology and astronomy programs there and find out who is affiliated with the RISE team, and if they're interested in doing graduate level research there or postdoctoral research. To learn more about our team, you can go to ris4e.labs.stonybrook.edu to learn more about what we're doing, and we have a occasionally updated blog by different team members describing the level of science that they're doing as well. And then finally, you can see what we've done in the fieldwork by going to the reportingrise.com website. And that site, I'll mention, was completely generated by the journalism students. It's really highly polished. They did a fantastic job on that. And it really it kind of humanizes our field team and shows the personalities behind all the work that's being done.
It really is impressive. Now, the one thing you didn't say is, what is your social media handle that people should follow?
Thank you. On Twitter, we're at RIS4E_survey, and I think it's the same thing on Facebook as well.
Okay, and survey is SSERVI because NASA acronyms are strange. But we love our NASA acronyms. We just have to make fun of them at the same time.
And if you want to follow me on Twitter, I'm at the real T Glotch, in case there's any other big ones out there.
I appreciate that. So this has been great, and before I let you go, I'm just going to ask, what one thing do you think is the most exciting thing that your team has done so far science-wise that everyone should know about and probably don't?
Gosh, that's a hard question. I feel like we've done a lot of really cool stuff.
Or what's your favorite one that you love to tell people about?
So right now we are working, this is something I'm going to be proud about later. So right now we're building an experiment in the Brookhaven National Laboratory in the X-ray synchrotron beamline, where we're going to be shooting samples with lasers at the same time that we're shooting them with X-rays to understand the space weathering process a little bit better. And it's just a super complicated engineering problem. I got a great postdoc who's a physicist who's never been an engineer before, but he's really tackled the problem, and we're really kind of tackling this cool engineering and laser physics and X-ray physics problem all at once to understand how the solar wind and micrometeoroids impact airless bodies. It doesn't sound as cool when I describe it that long, but believe me, it's really neat.
And what's really cool is you're essentially doing all of the things that create superheroes in the Marvel Universe or the DC Universe even. And
Try
you're
not to
doing
end
it
up
to
with any,
rocks, so please do not create any super evil villains with your
no,
rocks.
try not
That's
to end up
awesome.
with any green-skinned postdocs.
Yeah, that sounds like a really good goal, or ones that have like super speed or something like that.
Yeah, if anyone's got super speed, I want it to be me. So I got to get in the lab more.
That's the only way to get all of our paperwork done, I think.
Yeah.
So thank you for doing this. I can't imagine the amount of administrative work you've had to take on in order to lead such a fabulous project, but you truly are enabling a lot of really good science to take place. I hope everyone goes and checks out your site. And hey, join us again next month on the first Tuesday of the month at 8 p.m. Eastern, 5 p.m. Pacific, when we bring you another team from the great Survey collaboration. Do you know who we're going to have with us next month yet, Andy?
Boy, I wish I did, but there's plenty to choose from still.
And March is going to be an exciting month because it's also the Lunar and Planetary Sciences Conference that we will be at. And so come check us out and check out our science. And if you'd like to get involved in doing some science on your own, check out cosmoquest.org, where we're helping to find the landing site for the Mars 2020 rover. And we will be helping the OSIRIS-REx team get that sample safely back to Earth. So go do your own science, and we hope to see you next month. Thanks a lot, everyone. Have a
Thank you
great
very much. It's a lot
morning.
of fun.
Thank you.